Good morning all. I've got lots of posts, so let's do a post bag. Right, random order again today. I have always thought actually that Postbag could be a useful vehicle for just doing general blog or vlog updates. So these are resistors, there's quite a lot of them. But it really hasn't panned out that way yet. I've just made Postbag. So maybe I'll introduce another video type which will be a general vlog. But what I wanted to say today is that I'm doing another project at the moment. It's kind of training or tuition sort of thing, and it's going to be going on for a couple of months. So my videos are kind of just fit them in as and when I can at the moment. So they are tending to be more just show me doing things as I go along. They're a little less well planned, and as such you're going to see more of the mistakes, more of the errors for a couple of months. So this is a set of 1280 pieces, 64 different values, and here are all the values. 1 ohm to 10 megohms, quarter watt, metal film, resistors, assortment kit. That's probably what the eBay listing is called. I probably won't have to read it out when I show the eBay listing. These are all handwritten, marked up with their values. So we've got 47k there, 4.7 meg. Is that 10 meg and 150 ohms? Is that? I think that's the ohms scroll that this particular person is writing. 3.9 k ohms. And this, I think, was for the vocoder project, although, of course, you know, a set of resistors is sort of generally useful for all projects. I think I thought at the time that 64 different values was the biggest number of different values that you could get in these resistor assortments, but I've got a funny feeling I found one with more values now. Yes, this one is in my watch list. You can see here watching. My screen's doing strange things. 2600 pieces with 130 values, quarter watt metal film resistors, assortment set, 1%. I think my one's 1% as well. I didn't actually say that, but I'm pretty sure they're all 1%. This one, which is not the one that I'm showing, this one is $8.44 with $2.19 shipping, and that's the Sea River 2009. And this is the item I actually bought. Yes, you bought this item. 64 values, 1280 pieces, 1 ohm to 10 megohm. I said I wasn't going to read that, didn't I? It doesn't actually say 1% in the title there. So let's have a look a little bit further down. Right, okay, so yes, these are resistor tolerance plus or minus 1%. Let's have a look at the table of values, because the problem with this sort of thing is that you're never quite sure whether you're getting a good spread of values. The only way really to tell, I suppose, would be to plot these on, I don't know, log graph paper or something and see whether they're nicely spaced. But I mean, if we look at some standard values like 1k, what have we got either side? 1.5, 2.2, 820 ohms, 680 ohms. Let's go to 10k, 8.2k, 7.5k, and above 15k. So there's no 12k, for example. Let's go to 100k. It's there. So there's no 120k. In fact, 12 seems to be a number missing in quite a lot of places. We've got 10 to 15 ohms, 100 ohms to 120 ohms. So we've got it there, and then 150 ohms. So you just have to be a little bit careful, because you never know whether they've cherry-picked all the good values out for other kits and we're just getting the dross. I didn't quite finish this, did I? This kit of 1280 resistors was $4.56, free shipping, and this came from Chow Chung Yi. Right, let's do this one now. This is from Aki City, who I vaguely recognise the name. Integrated circuits. I don't think it is integrated circuits. Let's have a quick look. No, it's actually supercapacitors. So two little supercapacitors here. They're clearly designed for vertical mounting because of the way the PCB pins are welded on, so it sits up on a board. Also, they're 5.5 volts. You can just about see that there. So they're also clearly intended for digital circuits. And in fact, what this would typically be used for, I think, is sort of memory backup. And that's exactly what I bought them for. I want them to hold data in the memory chips of my 8-bit computer project. So you can see that these are 1.0 farads, 5.5 volts. Now fairly clearly you've got two discs in there, kind of held together with heat shrink that has the printing on it. So this is presumably two supercapacitors in series. Now what about balancing two supercapacitors in series? Let me just focus on these. So for example, when we have 6 supercapacitors in series, like this 6 supercapacitor module, and incidentally that's still reading 2.5 volts. That must be 4 or 5 days after I did that video on fitting this meter. Yeah, we have these protection circuits so that one supercapacitor can't go too much over voltage because the protection circuits will kind of pull that supercapacitor down, and it kind of balances them all out. But here it doesn't look to me like there's any sort of balancing. So what are they doing? Are they just using very well matched supercapacitors and just sort of hoping that one won't go wildly out of balance in relation to the other? It's hard to say. Right, let's just do a quick check to make sure these things have no significant voltage across them. Well, that just looks like a few millivolts, so that looks discharged. I'm just going to plug that straight into the back of this power supply. It's a bit naughty. Normally I'll put a diode in here so that when I turn the power supply off, I haven't got a voltage, well, and current source potentially backfeeding into the power supply. So I'm hoping this won't cause any major issues. So I'm going to limit at 5 volts there. What shall I limit on current? Probably something quite low, like 100 milliamps. Even that's probably quite high. Yeah, let's limit at 100 milliamps and start charging that capacitor up and just see how quickly it gets up to 5 volts. Let's just save that. Okay, let's do it. Now, which is positive? There's kind of an arrow pointing to this top surface. These look like lithium button cells, and on those, certainly the big flat wide area is normally positive, but that's not necessarily the case on these. So let's just check both of these again. I'll go positive at the bottom. Right, so it looks like positive might be that big flat wide surface. Let's try this one. Unless these have drifted. Oh, now that one's the other way around. So I don't really know which is positive and which is negative, because one is the other way to the other. So that's a bit tricky. That one's got more millivolts, so it's perhaps more likely that this surface here is positive, but it just doesn't say. I'll have to look at the eBay listing. Right, so this is the item. It's 2 pieces, universal 5.5 volt. So yes, that would be 2.7 volt supercapacitors in series, wouldn't it, roughly? 1 farad, so they're probably 2 farads each, so in series they become 1 farad. Supercapacitor V-type, so vertical type, button smart 5mm thickness, presumably. Capacitance, 2 pieces for $1.39, free shipping, and I got these from Hero Neo 2012, I think it is. But I still can't work out from this which is positive. We've got various images here. Again, these I think have arrows. Yeah, you can just see between the 2 pins some arrows. Oh, that's better image. But what do they point to? Do they point to positive or negative? There's a little diagram of dimensions there, but still no information. Ah, wait a minute. Yes, there is. Let me go to that diagram and get the enlarged version up. Yes, I don't know whether you can see that. I don't know whether it's on the screen, but down in the bottom right, there's just the merest hint of positive being on the larger surface and negative being on the smaller. Okay, so I think that clears that up. Right, so I think I've got this the right way around. Now I can't clamp these screws down on the pins because they're just too short, so I'm going to have to hold it there, which is probably not a brilliantly clever idea. 5 volts, 100 milliamps. Let's see how quickly it charges. Oh, I'm looking at current. 2, 2.5, 3. So it's going to take 10 or 15 seconds, 20 seconds maybe, to take that all the way to 5 volts. Now if I switch that off, we've got that 5 volts on the output of this unit, but this unit's not putting anything out. I don't know whether that's necessarily a problem. Let's switch it back on and it should jump. Oh, it's back in current again. Should jump back to that voltage that it got to. So we're going up to 5 volts. That's gone into constant voltage. And so that's the capacitor fully charged. Yeah, about 20 seconds at 100 milliamps, something like that. So if that was 20 seconds at 100 milliamps, then this lead, which probably draws about 20 or maybe 30 milliamps because it's got quite a low value resistor on it. Where's positive? That's it's that way around, I think. Then that should probably sit there lit up for around a minute or so. Let me attach that properly. Right, that's lit up. Do I have a stopwatch? Yes, I do somewhere. Right, I couldn't find that stopwatch, and then Sky TV rang me and tried to sell me an upgrade to my Sky TV package, but that's still running, and that must be a minute or so later. Maybe I will put the stopwatch on now. It's a bit after the event, but I'll set that going anyway. Stopwatch. Right, I'll let that run for a couple of minutes and we'll just see how far that gets. Yeah, of course, this is very unscientific, isn't it? Because this is not a resistive load. This is a mixture of a resistive load in series with a semiconductor. So I'm not sure this is really going to tell me very much, but I would expect that to sit there for, I don't know, 5 minutes or something. Right, let's do another one. I've left that there just to... oh, it's still quite bright. Doesn't look terribly bright, but yeah, it is. Right, let's have a look inside here. What's this say? Just electronic parts. I think there might be a somewhat ironic item in here. There's a breadboard. Oh, this is that transparent one I bought. Yeah, it'd be interesting to see what that's like. There's something in a box, and there are some aluminium knobs here with little pointers. Right, let's see what's in this box. Oh, it's a little timer. I could have used that to time that, couldn't I? Love these things. Well, I love them when they got batteries. So yet again, this is one of these annoying ones where they've sent it without batteries because, well, actually these are the Chinese sellers who... Oh, that's too big. These are the Chinese sellers who are really sticking to the rules and not sending lithium batteries through the post. So let's see what battery this needs. That's still going, that is. I've put a sort of foam rubber block there to put a shadow over it so we can watch it. Here's a smaller screwdriver. Let's see what cell this thing takes. Oh, it looks like it's an LR44. I've got one of those somewhere. Right, yeah, Power Shop to the rescue. LR44. Let's shove that in. Oh, it's making a piezo beeping noise. Yeah, that looks good. Oh, big display as well. I like that. Let's get that cover back on. This really doesn't fit at all well, which makes me think it probably isn't an LR44. It's one of those thinner ones, isn't it? Like an AG12 or an AG10. I think I'm going to have to look at the listing if I can find it. I think this is quite old. To see what battery that takes. There wasn't... Oh, there is. There is an instruction leaflet. Right, that will help. Let's read that. Oh, well, I say instruction leaflet. It's a tiny piece of paper. But what... Oh, does it not tell me the battery type? No, it doesn't tell me the battery type, so I'm just going to have to do it by ear, I think. Right, I've got some AG12s. That's the LR44, I think the AG13. Got some AG12s and AG10s. The AG10's pretty thin, but then the AG12 is probably easier to get to. Oh, heck. So let's try that. Right, so the AG12 does look like a better fit. Let's put that on. Lock that in there, see if that will press down. Oh, that's good enough. Yeah, well, it probably is the AG10 because that does seem to be bulging a little bit, which isn't brilliant because it's going to interfere with that magnet for sticking it on your fridge. But yeah, that's working nicely now. That's getting dimmer. Start. Oh, I love these things. They're absolutely brilliant. What does this do? Seconds. Oh, that's mucked it up. That seems to be incrementing minutes. Oh, it's a countdown timer, of course, isn't it? So 1 minute, 7 seconds. Start. And now it counts down. So what if it's at 0? Let's wait till it gets to 0 and then see if it counts up. Was it counting up just now? Right, a couple of seconds to go. Let's just hear it beep. Oh, that's nice. Right, let's stop that. How do I set that to 0 then? Maybe I'll have to... Well, maybe I have to scroll it all the way to 0. I mean, I know you can't count down from 0. Oh, now I'm going to have to do that one. Yeah, I know you can't count down from 0, but it must have been set to 0. I could take the battery out, I suppose. That would be the other way to do it, wouldn't it? Oh, that goes above 60. How annoying. Right, I've got it back to 0 minutes and 0 seconds. What happens if I start? Nothing. It won't count from 0 minutes and 0 seconds. I suppose that's fairly obvious, isn't it? Let's count down for 3 seconds. What fun. Right, this is a solderless breadboard. I can't quite remember how many tie points. I think it's 400 or 400 and something. So let's take that off its blister pack. Seems a shame to destroy the cardboard. Is that also the instructions? No, no instructions. And I suppose what I ought to do is peel this back a little bit and take a look at the these metal things. I mean, one good thing is that you can see the metalwork inside here. So we've got the 5-way connectors for the power rails. I assume they're joined. There are no gaps in the red and blue lines there. These should come off, of course, shouldn't they? Yes, they do. But this plastic is not going to be as soft. This is probably a more brittle plastic, as soft as the white ones. So, oh yes, you can hear it sort of creaking. I'm not sure how easy that's going to be to clip back on, but by the feel of it, not very easy at all. Yeah, actually, I don't think that's going to press on at all, and it's all starting to show sort of stress marks and cracks. So I think probably the best thing to do here is to trim that down there as accurately as I can and remove that, and then the way to fit that back on is to probably put it on high and slide it down. Has that gone on? No. Oh, it's because the foam rubber's getting in my way of sticking those together. Oh, they don't mate together very easily at all, do they? I remember people saying that these transparent ones weren't any better than the plastic ones in terms of quality of the metalwork, but actually they're a lot harder to attach the parts together because this plastic doesn't have the softness of the white plastic. Right, I've rather brutally peeled back some of the self-adhesive stuff on there, and I'm trying to get one of these out, but they seem really quite well bedded in. Ah, there we are, that's coming out. Let's take a look at the funneling. Well, from what I can remember of the funneling on the other ones I've looked at, this doesn't look particularly good. It doesn't look like the funneling is particularly wide, and therefore I'm anticipating some problems pushing wires into those, because the wires just simply hit the top edge of that metal funneling, and of course you can't push it down because it's just sitting on top of that piece of metal and won't slide into, well, the mouth, I suppose you'd call it. Right, here's some two-legged capacitors. Let's just straighten those out a bit. See how easy they are to plug in. Oh, well, that one. Yeah, that goes in fine. Maybe the guide holes in this transparent plastic are a little smaller and therefore guide them in, but no, they seem actually fine. That one's fine. Let's just bend that out to its full pitch, which I think is 3/10. Oh yeah, they fit in there fine. I'm not having any problems with that at all. Yeah, that's fitting in. And it's got a nice sort of grip feel to it. Or maybe I was overcritical of the funneling on there. But yeah, I'm not having any trouble with that at all. Let's try the power rails. Put that one across the power rails. Ah, that's proving a bit more tricky. Yeah, that's not, oh yeah, that's not going in there at all well. Let's try another one. Yeah, it's going in there. Yeah, having a bit more difficulty with these power ones, but not seem to having any trouble with the sort of chip connection ones. Yeah, I kind of give that, I don't know, 6 out of 10. And finally the knobs, and that's getting very dim now. That's barely on at all. That's probably been 5 or 10 minutes, but of course it's a non-linear discharge, isn't it? Yeah, these are just aluminium knobs, which seem to have a plastic insert with the splines, I suppose you'd call them, for fitting onto those splined pots. These are intended for the vocoder. Let me just bring the project box out for the vocoder. Here it is. This one hasn't seen the light of day for quite a while because it's what I class as a sort of winter project. But what have we got in there? I think there's a board in there. Yes, here is a board that I'm in the process of making up. So the pots, these are the pots with the splines. So let's take a look at fitting that on there. Right, so these fit on here. Oh, it's quite tight actually. But yeah, that is sliding on. Yeah, that's fitted on quite nicely. Oh, I didn't index the pointer properly. Let's try again. So what's the range of movement from there? So the middle is with that completely horizontal, and I'll want that to be lined up with the knob pointing vertically up. So I think it's like that. So now it goes from there to there. Oh, it's not quite centered, is it? Oh, well, it's good enough, isn't it? Yeah, that fits on there reasonably well. I think those look quite nice, and will look quite nice on the front panel for the vocoder. Let's just get that. Yeah, so here it is. Still doesn't have many modules on it. I started fitting a jack socket there. I was using these knobs, but let's take one of these and that will fit on there. I just think it looks a bit nicer. It's quite a tight fit, but yeah, I think that just looks a little bit more. It's very dusty, this, isn't it? Just it looks a little bit more the part than these rather cheap plasticky ones. Right, so these 3 items you can see are so old because I bought them back in February that there are no longer links through to these items. They all came from CZB 672 1960. Let's start with the clock. That was just $1.78, presumably free shipping. They generally are. The breadboard was $1.65, and the set of 10 pieces volume control knob was $1.47 for those 10 pieces. Now in the description below the video, I will try and get links to all of these 3 items because this seller is almost certainly going to be still selling all of these items. And so these are today's Postbag items. Now a huge thanks as usual to Patreon supporters who make Postbag videos possible. Click this link if you want to support me via Patreon. Couple more videos up here if you want to watch more of my stuff. And this icon here is to subscribe to my channel. Cheerio.